Welcome to our roadmap talk. I'd like to ask for a show of hands of who has ever had an idea for a game that they wanted to make, and then they went on to make that game, and it turned out exactly like they thought. Really? No one? Not a single hand in the audience. So we also have this problem. We think we have this amazing idea, we work on it, we want to talk about it, and then we show it to you, and then you tell us like, no, this doesn't solve my problem at all. And that's one of the things that makes it very hard for a technology company like us to figure out how much do we share. How much of what we're working on do we share? Do we only share when something is, completely finished and shipping, and do we then show it in a keynote, or do we talk about it much earlier? And we made a very conscious decision as a company that we're going to be the company that's going to share early, and is then going to be yelled at when plans change. This intro is sort of hoping that for the things we're going to mention here, I can guarantee you that the things we'll mention are the things that we're working on today, the things that we are thinking about. I can guarantee you, they will change. They will change. The things that we today think maybe we can ship relatively soon, there's always something that happens. Something else needs to be happened first, or maybe it turned out to be the wrong thing after all. But when we think about what's best for our developers, we decided that even though if it might turn out to not completely pan out like that, it's still better for developers to have an idea of which direction we're going, what we are thinking, than if we would totally not share. So that's what we're going to do. We have a whole bunch of our engineers with us in the room here. The format that we are going to use here today is we have an hour and a half, and we have about 6 people that are going to do about an 8, 9, 10-minute talk about one area and the kind of things that we're working on in that area. We're going to go through 6 or 5, hey, Ryan is here, so 6. Hey, Ryan. Ryan was stuck in another talk. About 6 of these. And when that's done, we're going to open the room for questions. And the questions can be about any topic. We'll all be on stage, and we'll stay here answering your questions until someone kicks us out of the room, basically. All right, so we're going to start with Russ in the area of 2D.
Hey, guys. Can you hear me all right? Okay, so we're going to start with 2 dimensions first, and we'll add the 3rd dimension later, yeah? If that's okay. Cool. So I'd like to give you a little bit of an update about the 2D features, why we worked on what we worked on, and what we're going to work on next, okay? Most important of all, I want to stress that a big part of this is bringing you guys into our development. We're really interested in what you're doing with these features, and we want to know more about how we can support your workflows. Okay, so with 2D. First of all, we've completed a cycle recently of focusing on foundations in 2D. And the features that have been released as a result of this are already out there. You can see the improved sprite data. That's where the mesh has been enhanced behind the sprite. Sprite atlasing, which is coming soon. That's an improved sprite atlas, more versatile, more powerful. There's better ways for you to do your packing, better ways for you to do variants. We're looking at sorting groups. So if you've already used those, that's a really good way of grouping your renderers together to make sure that they're being rendered in an order that you expect. Axis distance sort, which supports rendering along an arbitrary axis. You want your order of rendering to be from top to bottom, or from left to right, or some custom axis that you define. And lots of other rendering improvements that you should see in the actual performance of the tools. This also led to better editor tooling and better APIs. So for example, in the Sprite Atlas, you can now get access to a sprite inside an atlas very easily. Now, alongside foundational work, we've been focusing on world building, right? So this is a huge area of focus for us. And in 2D, this has resulted in features such as the 9-slice sprites, which allow you to kind of define the slicing in a sprite. And then when you scale the sprite, we will scale according to the location in that slice, right? So corners don't scale, edges scale according to the axes, and we scale or tile the center. Also in this is the sprite mask component. This allows you to use a sprite to mask out other sprites or groups of sprites or even particle systems. What else is coming soon is the tile map. So this is a really, really powerful tool. For those of you who are building tiled games, right? You're building games on a grid, and you want control over that. You want to enhance the designer's power from that. So we've got brushes that can be customized so that when you're drawing tiles, you can lay down not just graphics, but also functional pieces, right? So I'll give you a link to an experimental build later where you can check out the latest experimental version of the tile map. And Smart Sprite, which is for more organic spline-based workflows, which allows you to tile sprites along a spline. Okay, so the next part, and again, this is all built on top of that foundational stuff, is animation. So we're looking at bringing character animation, skeletal character animation specifically, into Unity, and supporting a lot of the workflows that a lot of you are already using. So you're going to see things like fast and easy bone creation. You're going to see auto rigging, right? You're going to see rigging. Sorry. You're going to see auto skinning as well on those splines, and improved keyframing for all of this stuff. So all of this, or some of those features that I've mentioned, will be built directly into the sprite editor that a lot of you are already using. So at the same time, we've been making improvements in many areas. Not all of them directly features, but we've been working, for example, with the documents team to make sure that the documents you get that support these 2D features are clear, and that you know what we're doing, what we're working on, and what kind of procedures you can do with these features. We're also working with multiple teams within Unity to improve integration of the 2D features with other aspects of Unity. Another big area, so more physics. So there's a lot of stuff happening in physics, 2D physics specifically. We're adding, for example, manual physics simulation. We're going to be adding a low-level API to expose low-level collider primitives. So these are primitives that don't require you to have a 2D collider component attached. So these are really super fast. You can do intersection tests really, really quickly. So lots of research in 2D physics into areas like simulation, animation, performance, as well as enhancing the rigid body 2D. Now, I'd like to leave you with a couple of links here that I highly recommend you follow if you want to know more about what we're doing in these areas, because these will be updated live, and we want your involvement on them, right? So please take a photo of these if you need them. This is where all of that stuff is happening. The 2D experimental builds, which is where when we're trying out a new feature, it's in development, and we really want your feedback on it. We want to know if it's doing what it's supposed to do. As well as the 2D physics roadmap, which is a very clearly spelt out roadmap of everything that's happening in 2D physics. Check out these links. On that note, I'm going to pass it over to Ryan, who's going to talk to us about the build pipeline. Thank you.
So Ryan Caltabiano, part of the build pipeline. That's for player building and asset bundle building. We wanted to talk a little bit about the features we've been working on a lot behind the scenes to try to make working the editor and deploying your content worlds easier than it is today. So under that topic, the first thing we wanted to mention is the new addressable asset workflow. This is based off of work we've been doing with what we're calling the new resource manager, which is a replacement for the current asset bundle manager, and also the refactored build pipeline. This allows you to very easily specify what assets you want to be able to dynamically load at runtime. It will understand where that content is deployed, so you guys don't have to go and find out where you deployed the asset bundle to. It will download the content, download the asset bundle, the correct version of it, load the asset bundle, and load the object that you want at runtime with only one line of code. It'll also do ref counting, so you can take so as you load and unload content, it'll automatically load and unload asset bundles as needed, so it'll manage your memory for you. There's also the new data list player and hot reloading. Joachim mentioned this previously at, I believe, GDC and Unite as well, the last Unite. This allows you to play your game on the device while it's connected directly to the editor. As you're editing objects in the editor, they'll be updated on your device. So this gives you an improved workflow and faster iteration time for testing out your games. This is all built on, again, the addressable assets and the resource manager and the refactored build pipeline that we've been working so hard on. Another thing that we've heard a lot and need to do is the asset bundle patching system. So we are working on, behind the scenes, trying to get content-aware binary delta patching for asset bundles. So that way, when you build a newer version of an asset bundle, you don't have to force your users to download the entire asset bundle. The new build pipeline produces artifacts that tell you exactly what's in the asset bundle, where it is, and this new data allows us to be able to make content-aware binary patching and make the smallest patch possible for an asset bundle. That way you guys will be downloading really tiny patches instead of an entire asset bundle. We're also working on a new build configuration system. This is going to replace the whole player settings, graphics settings, your build window with a unified configuration system. So we'll have one place to go and set up configurations. It'll be a hierarchy based, so you can set up a base configuration and inherit that base configuration in your other configurations and only override certain settings. These will also be used for your importers and everything across the board on Unity, so you can just select a configuration, build that configuration, and that will target your high-end or low-end Android devices, or your desktop or your console. And unlike today, everything will be nice and clean and separated. We're also looking at asset variants. Today with asset bundles, you have to build very specialized asset bundle variants, and we're trying to move away from that and get you guys a workflow that is more data-driven, so that way you can do runtime remapping of assets, so you can quickly switch from your localized, English localized content to your Dutch or French or any other, or you can quickly dynamically switch out between a holiday themed skin or a regular themed skin without having to build special asset bundles. Again, this is all built on the core frameworks that we're building for the resource manager and the new build pipelines. And then finally, we're also trying to build, or we'll be building in parallel to this, a content hosting service. This will tie into the build pipelines, the build reporting, and the history and all that, so that way you can deploy your content to the cloud, to our content hosting service. We'll host it up for you guys. Your game will be able to connect to this, download the latest version of the content. We've also talked, the system is also talking, we've also been talking on how to integrate patch generation into the solution, so when you deploy your asset bundles and the artifacts with it, we can generate tiny patches for you guys, so you don't have to generate the patches. We can download that, and we can do things like A/B testing, time-limited content, and any other type of system that you guys are looking for. That's kind of the whole of what we're looking to do in the next couple of years, and hopefully actually shorter in the next couple of years, where most of the stuff is all stuff that we should be having in beta or hopefully released by mid-next year to the end of next year, hopefully. So I'm going to turn it over to Joachim and talking about some of the core tech.
Thanks, Ryan. That looks pretty awesome. I'm going to talk about core features in Unity. The first one I want to talk about is the asset import pipeline rewrite that we're working on. So we have a team that is basically rewriting from scratch our asset pipeline. And there's a couple of sort of like core principles that we're going with. So the first one is that we really want that asset pipeline to be extremely scalable. And the main way in which we're doing that is that we're turning it into an asset pipeline that is completely on-demand completion and on-demand importing. And the reason for that is because we want to make sure that no matter how big your project is, the number of assets that need to be imported scale with the number of assets that you're working with, as opposed to the total project size, so that even if you have a terabyte project or something crazy, you don't need to have all those assets imported on your machine. The second thing is we are moving to a model where multiple processes import your assets in the background. So if you're importing a texture or something, that will happen in the background in parallel to you working in the editor, and it will hopefully not interrupt your work. To do all of this, this import pipeline is really built on a deterministic system. So basically, today we have a cache server where we basically upload the artifacts to, and it's kind of like a system that is a little bit bolted onto Unity. And instead, in the new system, the cache server is sort of an inherent part of it. So basically, the cache server is always present. You're basically loading effectively directly from what is today a cache server. And that requires that all our imports are completely deterministic. And we'll have a lot of tools that make it easy to tell you when you're not writing deterministic asset post-processing code, if you write your own asset importers and so on. So there's a lot of work going into that. Basically, we will be shipping both the old import pipeline and the new import pipeline in parallel over multiple releases, where you can basically dynamically switch it in and out. So you can slowly start to transition over, change some of your code to use it. All right. So the next thing is load time optimizations. So we're putting a lot of work into that. So we are doing scene load time optimizations, basically in the innards of our code, in the loading code, just optimizing it, profiling it, and optimizing it, making prefabs load faster, making scenes load faster. And then there's also a couple sort of like specialized controls that we're putting in there, like when you use additive scenes and you're loading a scene and you're not sort of like you're loading a scene and you're unloading a scene and you have this very streaming workflow, then we will give you the ability to define a chunk allocator for it that makes it so that all of these allocations go in one big block of memory, and then only when the scene unloads will that memory be released. So if there's sort of a very specific way in which you're working in the streaming workflow, then you can take advantage of that and get much better memory packing, much better allocator efficiencies out of it. So you basically have to play by some rules, but then you get some big benefits. Another very important thing we're working on, I think, is the package manager. So the idea with the package manager is twofold. First of all, ourselves, we would like to work more on Unity like developers on the asset store actually work. We want to move more and more code of our own from the C++ engine into high-level C# code, because we think that makes it much more flexible for you guys to actually see the high-level choices we make and to be able to then modify them, where you want to maybe make different choices. And the package manager, basically, we want to ship all of our different features. We want to ship them as separate packages that you can download and update at a different frequency than what you get in with our normal editor releases. And packages, effectively, they have a manifest. In the manifest, we store semantic versioning information. You can depend on packages, and with these packages, you will be able to create your own packages. The packages don't live inside the project folder, so they don't have to be in version control. When you open a Unity project folder, there's basically a manifest file saying what packages do I have, and then Unity will automatically download these packages for you. And so it makes it very easy to then upgrade packages, go between different versions, try something new out, try experimental packages out, and sort of get these workflows much tighter in Unity. Part of that is also modularization of our own code base inside Unity. That's a really big effort right now. And that's partly also to support the package manager. Because if we want to make semantic versioning work in Unity, so the ability for you to say, okay, I depend on this specific version of the physics module, then we need to have split the engine really nicely into different modules, and it allows us to iterate faster and these kind of things. So that's the package manager, that's modularization. And then we have a rewrite of the profiler coming up. So basically the approach is we want to make it much easier to put additional data into the new streaming profiler. So right now we use the timeline profiler to basically time different time on the job system, give you feedback about how much time an operation takes. But we want to put additional data on it that you want to put in there. Maybe you want to put positions of a player into it and analyze that data and look at it. So it's more like a data framework where you can really analyze what is going on in your game. Another part is the memory profiler. On the memory profiler, we want to give you very detailed data about where your managed memory goes, how it looks like, how it's fragmented, how much each of your allocations takes, and what is in those allocations. And we're also working on making, giving you overview into the C++ allocation, so fragmentation views, so very detailed views that let you analyze your memory. And then lastly, we're putting a lot of effort into jobification. So yesterday you saw the work that we're putting into the C# job system. I'm not going to dive much into that, but generally in the engine, we're doing a lot of work in jobifying our C++ code itself. A lot of work went into the is going into the transform component, for example. Our ability to write into transform components from multiple threads, and just being able to as a result to get just massive speedups when you have multi-core machines. So basically going through a lot of different subsystems these days and just optimizing them, jobifying them, these kind of things. That's an overview of some of the most important things we're doing with in the core teams. So with that, Sean.
Hey everyone. My name is Sean McClelland. I am part of the user experience team here, and I'm going to give you a preview into some of the things we're working on in the editor. So one of the first items here is UI elements. So this is a new editor UI toolkit. It supports modern sort of styling such as Flexbox, CSS, our own internal Unity style sheets, and it's primarily for building in-editor UIs. So this is currently exposed in an experimental API, so you can play with it currently. The next thing that we're working on is a hotkey editor. We feel this is a really powerful thing to deliver to users so that you can create your own custom hotkeys. If you're asset store developers, you can look into what the currently assigned hotkeys are in Unity. And we see this as a really powerful way going forward of being able to create hotkey context and create more editor context. So as you move through the editor, we can customize the hotkeys to be a little bit more flexible. The other thing we're working on is the preset system. So on a component, you can basically store a preset, you can load a preset, you can have multiple presets. You can also store presets at the asset level, so you can have presets for FBX files, presets for your audio files. And this is a really powerful way going forward to set up standards in your pipelines. So you can imagine having presets for just about every asset in your pipeline, as well as components and custom components that you're using. A big focus for the user experience team is just generic editor improvements. We've been talking with a lot of users, we've been talking with a lot of studios, and we're really focusing on editor usability. There's a lot of things that we can do to bring Unity up a bit as far as usability, as far as interactions go. And so that's been a big focus for us. So you'll see forum threads from members of my team and other people at Unity asking for more of your input. So guiding us on what we can do better, what are the workflows that are problematic. Last but not least, we are working on prefab workflow improvements. So this ranges from a number of things as far as how you interact with prefabs, how you open and edit prefabs. And for those of you in the audience wondering, yes, this will support nesting. So as you can tell, this is a big thing for us, right? This is finally happening. The goal here is to really drill down on prefabs, to make them more flexible, to make them more powerful, to make it so that they fit within your pipeline. So we're looking at nesting, we're looking at variants, we're looking at inheritance, how you can author prefabs, what the interface looks like, getting away from having to drag the prefab into the scene, for example, having your own context. So these are all of the things that we are currently working on in the editor side. And if you'd like to get a little sneak peek at the prototype that we have for the prefab workflows, head over to Ask the Experts tomorrow between 10 and 11, and you can meet with the team, get a little hands-on, and play with the demonstration. And with that, I will hand it to Tim for graphics.
Good morning. My name's Tim, and I work with graphics at Unity. And let's have a little chat about where we're going over the next year. So one of the big bets we have in terms of graphics is the scriptable render pipeline. Up until very recently, the rendering pipelines in Unity have been very black box. What this project aims to do is open these up into userland projects. This will allow you to completely customize the render pipelines, rewrite them to do whichever things you want in a very, very flexible way. This allows you from the ground up to either take one of our built-in pipelines and customize it for your special and custom effects for your titles, or you can completely disregard everything we've done and write your own extremely custom pipeline specific to your title. Internally, we are building a few pipelines. The first one is the high-quality render pipeline. What this pipeline is it's a high-end compute-based render pipeline that has all of the bells and whistles you'd expect to be supported in a top-end game that's being released these days. It's awesome, to say the least, and it allows high-end PBR, subsurface scattering, clustered forward rendering, deferred rendering, everything you'd really, really like in a top-end game. In addition to this, we're also working on what we call the lightweight render pipeline. The lightweight render pipeline is a non-compute-based pipeline. What this means is that it's designed for sort of low to mid-range PCs and low to mid-range mobile devices. The idea behind this is it's a very fast pipeline that will run exceptionally well for areas like VR and mobile devices. This pipeline will also have support for simplified PBR. It won't be as accurate as something that would have in the high-quality pipeline, but it'll allow you to do some levels of PBR and things like that in your titles. One of the next things we're working on internally is physical camera support. This is doing things like allowing you to set the aperture, the ISO, and everything on your camera. This will then feed into our post-processing. When this happens, it'll allow you to basically have a camera response to the environment that matches what you'd expect from a real camera. The one I missed there was render pass support. What this is it's a technique that allows you, if you're making a game that has tiled GPU memory, it allows you to stay on tile for the whole of your render. This allows you to get the speed up and advantages of tiled-based GPU performance. And it's a really, really nice way if you're shipping mobile titles to stay very, very fast. Next, we are improving our multi-sample texture support. This is very important if you are doing high-end VR titles where you're doing something like a clustered forward and you need to have a custom MSAA resolve on your textures. This will allow for better quality VR, essentially, in forward rendering. Another thing that we are doing right now is we are currently in the process of deprecating DirectX 9. It was originally released over 10 years ago, and in terms of what we want to do with Unity, it makes things a lot difficult if we can't say the editor supports compute power and that kind of things as you're developing. So what this will do is it'll allow us to push Unity forward much faster than we currently are. In addition to this, we are also doing a number of miscellaneous improvements to the rendering of the graphics. There's some things that are very simple, like we're adding shader dependency tracking so that it allows you to modify include files and it'll automatically update the shaders that are referenced by them, as well as improving our compute shader import pipeline so that it works in parallel and is much faster. So next, we have lighting. Earlier this year, we released the progressive light mapper, and a lot of the things we're working on in terms of lighting now are improvements to this functionality. So I'll just quickly run through a list of those that we're currently working on and will hopefully be released relatively soon. We are adding double-sided GI support, light map stitching support so that you have less seams in your light maps, indirect transparency support, better MIP rendering of light maps, HDR light map support, and improved tree and foliage rendering in the light maps. Finally, one of the bigger things we're doing when it comes to light mapping is adding a GPU light mapper. What this means is that hopefully light mapping times will be improved because we'll be doing a lot of the calculations on the GPU rather than the CPU. Next, we have post-processing. As you might have seen in the presentation yesterday, we have a very nice and versatile post-processing stack now. What we have coming is a second version of this. What this adds is nice support for user land projects, such as volumes and blending. So you can have multiple post-processing volumes in your scene, and as your character moves between them, you'll get blending. Integration with the scriptable render pipeline, so you'll have a nice way to have post-processing in the render pipelines. Easy extensibility. One of the big pieces of feedback we got from the first version of the render of the post-processing stack was that it was quite difficult to add extra effects. So we've improved the ability to add effects, so it's much easier now. We have a greatly improved bloom, improved mobile support, a rework of ambient occlusion, and we've added lens flares, or are currently adding lens flares. Finally, it also has improved timeline support, so it's possible to do nice things with timeline and post-processing at the same time. So finally, moving on to VR. Most of the things we're doing with VR at the moment are related to incremental improvements and more device support. So to start with, we are adding support for Apple VR. We are improving the post-processing for VR. Adding support for stereo instancing, which is another form of rendering stereo buffers. We are integrating VRWorks. And we are also adding support for the render pipelines into VR. I'll now pass you over to Lucas, who will talk about scripting.
There's a few things that we're working on in this area. And the first one is actually on the screen now, which is the .NET upgrade, which is actually in 2017.1. You can turn it on in the player settings. We did it as experimental first because it's like C# and Mono and the .NET runtime. It's such a big part of the product and all your products to sort of like, take a 7, 6, 5, I don't even remember, one out and then plug it in with a new one just felt too scary. But you can turn it on, especially for new projects. It would make a lot of sense. We're going to switch to Roslyn for C# compilation. We're already, like, the .NET upgrade already brings us to C#, I think 6. But the compiler that we've been using, that's part of Mono, it doesn't go beyond 6, and there's some nice things in 7 as well. And we would like to continuously, keep closer track with the rest of the C# world. So we're going to be switching to Roslyn for that. This one, I love this one. It's C#. Right now, all the C# files in your project, except the ones in like plugins and editor folders, we built them into one big assembly, assembly C#.dll. But that makes no sense, because most of these C# files, they don't actually need to talk to each other. So it would be way better if, if you have like one plugin over there and one plugin over there, if those would build into different assemblies so that you don't have to rebuild all that stuff all the time if you just change, the script of a rocket or some monster somewhere. So this will allow users to do this and asset store vendors to do it. And like the main driver for us, in addition to sort of cleanliness, is that it's going to result in much faster C# compilation times. So it's like the main driver is getting the iteration times of C# code faster. We're working on script behavior, aka mono behavior 2. When we designed mono behavior 10 years ago, 9 years ago, we had no idea what we were doing. We didn't. But it's such a core building block. It's very there's no way we can change for, people often complain about like the way the event order happens, or like I get my enable before my awake, or the other way around, or I don't get the disable. Like we know it's a pain in the ass, but if we change it, all your work breaks. So I think what's going to happen is like every 10 years we're going to do a new one, and we're getting close. So that's script behavior, sort of learning from these last 10 years and redoing the mono behavior. The old one will stick around, because if I were to stand here and ask you to rewrite all your projects to deal with the new event order, I'm sure I would not be the most popular guy in the room. Bye-bye Unity script. I guess that speaks for itself. I guess maybe it made sense back in the day, but C# used to be very verbose, but it actually got a lot better, especially if you look at C# 6 and 7. And we just figured it would be way better for us to like focus our energy on one language and making that one great, making it great in the documentation and in the tooling support, instead of spreading our energy over multiple languages. Another thing that we realize could use some work is the garbage collector. This is still in early stages. We're still, messing around with different ideas, but it's likely to be incremental. But the problem that we know we need to solve is that everyone wants to get rid of these spikes, and the way you do it today is just by making sure you try to not allocate anywhere. And it would be nice if that were to become much less important. And then the last one is a C# debugger for IELTS CPP. So if you run IELTS CPP on iOS or any other platform, you can actually debug it with the C++ debugger today, but doesn't look amazing. So this would allow the existing debuggers that you have, for instance, in Visual Studio and in MonoDevelop and Visual Studio for Mac, to make them work on IELTS CPP platforms as well. Now, let me poop on this party a little bit. Everything you heard are plans. They're plans. They're things that, in our minds, we're really going to ship, but who knows? They might be the wrong thing. We're all super happy, and we are working on nested prefabs, but we were also working on them before, and we made the wrong thing, and we had to start over. So take everything we did, interpret it as what our intent is, the problems that we are trying to solve, and not as a, Ryan said that this would ship then, what happened to that? Okay, we're going to open the room up for questions. If you have a question about roadmap or what we are thinking about in a certain area or what our plans are, come ask a question. I'll ask all the speakers to come up on stage, because we don't know which area your question is going to be in yet.
Hi, I'm John, Payload Studios. I would like to know, in our game, we have quite complex physics objects driving around, and physics is a problem. We tried all of the obvious things. We haven't dug down into the, I say as a physics debugger now, which is pretty useful, but it'd also be handy to get some more information about what's going on inside. I guess the question is, are there any plans to open up the physics a little bit more? provide more information?
Well, we have the physics debugger, and we're trying to do more visualization. I mean, beyond that, I mean, we try to add a lot new high-performance APIs, optimizations, these kind of things. But generally, opening up the physics API, I mean, you know, like, I mean, we use PhysX under the hood. I don't know how to make that sort of a open-ended C# API, to be honest.
And when you say physics debugger, you mean like the NVIDIA one that you can connect, right?
No, that's actually in Unity. So there's tools in Unity that visualize what is going on in the physics.
It's mainly, from our point of view, understanding what we can see that where the calls are coming in, but we don't really know specifically what each party's doing. We can make an educated guess. We can look at the physics documentation, but it's difficult to see, okay, which version of physics, and get the manual for that, and actually figure out exactly what's happening, and so we can make educated guesses about improving the physics.
We do have PPD, but it requires that you build with the debug version of the physics libs, which we don't currently ship at all.
Okay.
So we can use it internally, and source code customers could use it, but we've got no way to expose it right now. Maybe at some point, if we had, I mean, maybe when physics is a module, and we're dynamically loading it, maybe at that point we could maybe like link, you know, we could provide a special version of it that had the physics debug, and then you'd be able to connect PPD to that or something. But I think, yeah, today there's no way to actually connect it unless you're going to modify the source and modify the way we build it.
All right. Okay. Well, we'll note it as a feature request for sure.
Okay. Thank you.
All right.
Okay. Well, I think like a lot of us are making mobile game and well, game in general. And one thing while you're working with Unity is memory is important and garbage is garbage. And it's actually right now quite hard to pinpoint sometimes which part generate garbage, specifically on mobile. Do you have any plan to help us fix that in the future?
So in the profiler, you can see exactly which C# call. We're talking about C# garbage, right? .NET garbage.
Yeah. Well.
So in the if you open the profiler window, you can see how much garbage was created each frame, and you can see exactly which line of code it comes from. So the profiler can help with like finding the place in the source where the garbage gets created, and then there's a sort of like half-finished project that I worked on, which is like the memory profiler, which is on GitHub because it's it's too ugly to ship, but it's too useful not to have public. And that allows you to get like a snapshot of your C# memory so that you can see what is in it. For instance, like a lot of people use it, they find like they have 500 copies of the same wood texture, or they have like 30 megs of a string that says hello. Like there's a ton of stupid stuff that you can find with that. So those would be the two tools that I'd recommend you'd start with.
Okay, thank you.
There's one more part actually that we're doing about memory. Part of the C# job system, we're actually exposing sort of like manual memory management with things like native array, and those are actually already in 2017.1. So basically, they are a way of creating memory that is backed from actual C++ memory, and if you're dealing with sort of like large blocks of memory that you want to explicitly allocate and deallocate manually, then you can use those. And they can, at least if you have big chunks of data that you need to deal with, they're really useful for that.
And actually, in my scripting part, I didn't actually touch on the C# job system so much. You have a talk at 5:30 about it today, but it's going to be it's our way to allow you to write C# code that can actually do useful, like you can do multi-threaded C# today, but if you try to call Unity API, it just says, no, boink. The C# system is our way to let you write C# code on multiple threads that can actually do something. All of that system, it forces you to work in a special way, but it's a way that generates no garbage and where all memory comes from the C++ side.
So will the new script behavior system, will that take a more data-oriented approach? So, for example, more like a true ECS, so we can just
it's how we think that going forward, people that care about performance will be writing game code. But it's quite a different way to get your head around, so it would be good to already start getting used to the idea. It took me a few months to sort of like wrap my head around the whole idea as well. But like if you already know the acronym ECS, you're in a good place.
Cool. Sounds good. Thanks.
Good morning. Peter O'Loughlin from Fugro Roams. Just wanted to inquire about the roadmap for WebGL builds.
We actually don't have much WebGL experts. Do you have a specific question about the?
Just anything that might be on the roadmap. Ideally, our wish list would include things like threading, better memory management. We found that with web builds, you tend to it automatically allocates a certain block size, but if you're loading in and out a lot of assets, you can get fragmentation, and eventually you can use up all your allocated memory for your tab, things like that.
So in terms of WebGL roadmap, it's kind of tricky because in many ways we are constrained by what the browsers can do, right? We cannot do threading because the browsers cannot do threading. So like we have a team actively working on making WebGL, like our WebGL product better, but like it's still a nascent platform. It's an early platform. The browsers are still getting their stuff together. We cannot outpace them. But it's a platform that we do care about, and we think it's going places. And we're actually in the lucky situation that when the browser vendors make it better, like our stuff works better kind of out of the box too, which is nice for a change.
One of the things, so if you come to the Ask the Experts tent, we have a member of the WebGL team is there, and he can maybe go into some more detail with you about exactly what we're doing.
Okay, no worries, thank you.
Great.
Hi, sorry in advance for the maybe tricky question, but maybe also in the spirit of Unity without borders, I wanted to ask about the progress on like text and Unicode enhancements, right to left, languages like Arabic, Farsi, Hebrew, and stuff like that. And because like I'm building a game with a lot of chat features, so it's a bit hard to build with Unity because of text and UI support. So.
Come to Ask the Experts. We have the lead from the UI team is at the show. Oh, he's here. Come here, Phil. Come here.
Actually, why don't you two get a room, and we'll take the next question.
I had a specific question about the package manager. It sounded quite interesting to me. I was wondering if this also means that the build size of the actual Unity, like as an empty project, will also go down because everything will be separate from the packages. So I could decide, so I don't need audio or I don't need UI, so I don't need to build that with the Unity core.
Yes.
No.
Eventually. Okay.
Well.
Well.
Well, why don't you go first?
Eventually, that is the goal. I mean, we really want to, like, we're modularizing Unity and we're moving things into packages ourselves, and we want to end up in a place where you can turn everything off. That is the ultimate goal. Now, this happens in stages. So yeah. I mean, it's gonna happen over some time. And the first step for us is to just be able to ship new features with the package manager and be able to update them live. And then the second step is to take features like post-processing effects, HD render pipeline, those things, like like bigger features, and ship those as packages. And then there's going to be the asset store, and then there will be modularization, and eventually we will have this beautiful world of semantic versioning with everything in modules, and you can turn off everything.
But even before all that, like as soon as we modularize one part, even before we have packages, for instance, like on WebGL, if you don't we're already relatively far with if you don't use a certain subsystem, that it doesn't get included. So it's more related to our efforts of modularization to get the build size down than it is with the packages. But I'm glad you asked about packages because it's like the package manager, if we pull it off, and I'm not no promises, but it's the thing in the whole Unity ecosystem that I'm the most excited about because it will make the work that we do be much more like the work you do. When Tim works on the new post-processing stack, it's just going to be a package that's the same kind of package that you would get on the store or that you would use internally in your team. the work we do would be much less tied to specific Unity versions. We can ship updates, you know, like Tim can ship updates to like eager beta users every day instead of this sort of, you know, 2-week cycles of betas that we do. So it's going to be such a healthy thing for the ecosystem, but it's an enormous amount of work on our end because we have to change everything in how we ship and how we test and how we upload and how we do documentation. But I'm super excited about it.
That there will be for like the package system. I'm assuming that it'll take a while, of course. But is it like in 2018 there will be things rolling out, or?
We're starting to roll out the internal packages. We're starting to roll out this year. So
awesome.
And from there we just keep going. So.
Thank you.
All right.
Yesterday we saw the stack post-processing and the Cinemachine demos during the keynote. But in the stack processing we saw a short recording window for generating output from the cameras. Is there going to be any support for hardware encoding, using the chip on the graphics cards, like NVENC from NVIDIA, that idea?
We don't currently have anything on the roadmap for that, but it's something interesting, and I can take that back and have a discussion internally about that.
It would be nice to split that out and actually use camera output and stream that, that sort of stuff.
Yeah. Nothing currently, but
okay.
We'll keep it in mind.
Yeah.
Hi, so I have a question about terrain, because it's currently very static, and it's quite performance okay once you've built a terrain, but then if you want to switch out trees or do anything like that, it's a horrendous spike. Is anything on the roadmap to do with Unity terrain? Because it's kind of been languishing down there in research.
Yeah, so right now we're not actively talking about what we're pursuing with terrain because it's even a little bit further out than what we're happy to talk about in a roadmap session. But there are people actively working on it, and we have some exciting things coming, but we're not quite ready to talk about them yet at all.
So are they coming any time in the nearish future?
No.
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 Next century, maybe. Okay.
We realize it's a problem. The corresponding solution is like, it's not shipping this month.
On my machine at work, I tend to have anywhere between like 5 or plus versions of Unity like on my machine at one time. Have you got any plans to kind of build that together into one kind of Unity version manager type thing?
Yes, we're working on something, I think we call it the Unity Hub, which is going to take care of a lot of stuff. And one of the first things we're tackling is kind of managing multiple installs, making it that you can just open a project and the hub will figure out which version of Unity should be used, and then potentially even automatically downloading and deploying the versions of Unity for you as well. So you'll just have the hub and a project, and you'll open it, and then it will download and then it will just work. But there's a lot of stuff that's going to happen in there. I don't know exactly what the roadmap is, so I don't want to say too much. But yes.
What is the progress on the Gradle builds for Android builds? Because we currently stick with the old system, and it has many flaws, like this class decks build problem with plugins, and so we are pretty much limited there what we can add as plugins to the Android platform at some point.
I think I have seen some discussions recently where people were saying we should do Gradle-related things. I don't know if... Yes, come to ask the experts, and there's some mobile guys there who will hopefully know more than I do.
Do we have Android guys there? I'm
not
not
specifically,
sure.
but we've got enterprise support guys and so on who know mobile.
Okay, try they might have more information. We don't know. Which doesn't mean yes or no. It's just that none of us work on Android.
You mentioned about editor scripting UI changes. You mentioned CSS. Are you planning on rolling out better support for building custom UIs in the editor in the future?
Yeah, that's the UI elements work. So we see that as a modernization of sort of what we have with IM GUI. So basically being able to do better layouting, better styling, your own custom styling. So internally we're kind of dogfooding and using it for stuff and basically creating what we have as Unity style sheets, which is essentially CSS. So we do see that as a modern UI framework going forward for building editor UI tools.
And did you say there was an experimental build around somewhere?
It's in 2017 1. beta in the experimental namespaces. So yeah, go try it out and let us know what you think.
Release candidate.
Say what?
We have a release candidate out, right?
Oh, yes, we do. We do, yes. It's in the release candidate, which, yes.
Hi. You briefly mentioned content server. Could you tell us a little bit more about that? Will it be for pro users? Will it be something additional? Will it be a bit like Steam, where you push depots live?
Right now, it's still in the early concept phases. We haven't actually started work on it. We've done hack weeks before where we've actually built kind of a content delivery system, and we're kind of basing our current approach on that. So the general idea is you build your project either locally or in cloud build, and that generates a whole bunch of artifacts, such as the build report. The new build pipeline will generate additional asset bundle data layout information, and you basically push that up to the content hosting service under a specific version number. Your players will connect to the content hosting service and say, my game is this version. I have these version of asset bundles. What do I need to update? And they'll communicate back and forth and go, okay, you need these patches or these full asset bundles to download and get you up to date to the newest version. That's kind of where we're going with it. And the idea is to be a separate content hosting service that'll work cross-platform. So you can deploy your Steam game, and your Steam game can connect to this content hosting service to download asset bundles. So you don't have to deploy your asset bundles directly to Steam. You can just download them from our system or for Apple or Google stores.
Okay, thanks. Cool.
Hello, I would like to ask regarding the GPU profiler. As far as I know, there is nowadays no support on iOS and only limited support on Android. Are there any plans to support these platforms more?
Generally, we would like to, but a lot of the times it depends on what APIs the vendors expose to us. For some Android devices, it's very easy to get timings, and that's where we do support the profiler. But on others and on iOS, a lot of the times we can't get the data from the hardware, so that's why we don't have the support. We're always in discussions with the vendors to try and get them to open these up more and more, and it's something we always continue to push on.
Thank you.
Hi, there was mention of deprecating DX9, and I was wondering when that's going to happen, because I have problems with rendering in the Unity editor when I use DX11, so I have to force it to DX9. So I want to know when I have to change my laptop.
Well, to the first issue, please report a bug about that, because we've been through our internal bug databases and we don't have any bugs left to do with DirectX 9 versus DirectX 11 issues. So if there is some, we'd really like to know so we can fix them. And the timeline for that will probably be 2017.3.
Okay.
Most likely.
Thank you.
I have a question in regards to, I guess, UI elements and AR and VR. We mainly do applications, so business applications rather than games. And in that context, well, being able to open and actually visualize documents like PDFs and Office documents and stuff like that really makes sense. So in that regard, I was wondering, do you have any plans for XAML to be supported, for instance? Because I know there's a package on the asset store that does stuff like that, but it's like really steep in pricing and I don't know what. So it would be great if you guys would have some support for that natively or anything else in that regard, so that documents can actually be visualized in a Unity context rather than having to, well, go out of the application and revert to a flat app in case of HoloLens and stuff like that. So do you have any thoughts or roadmap in regards to that?
So to clarify, you're looking for basically a layouting system so that you can represent documents inside of the real-time application?
Yeah, indeed.
On the XAML point, we don't have any current plans to support XAML. The view, at least around UI elements, is it's more sort of HTML-like in the way that we build things. It's also currently only focused on the editor UI. We don't have any current plans of basically exposing that to the in-game UI system.
Okay. But are there any other things on the roadmap that you do in regards to business applications and documents and stuff like that?
On the short-term roadmap, no, but that's, as I mentioned before, the flip side is that that can change.
Yeah. Hi, Tomasz from Futurium. Do you have any update regarding Octane render integration with Unity?
Can you say that again?
Octane renderer.
We're currently doing alpha testing. We're going to start beta testing in a few weeks. So we're hoping to get the release out in like 1-2 months.
1-2 months.
It could be a bit more depending on beta testing, but that's the gist, I guess.
Okay, fantastic. Thank you.
Thanks, Rick.
Two short questions. One about the CSS. Is that also planned for the UI itself, or is it only inside the editor? Because for the UI, it would be useful too, in my opinion.
The UI in the runtime?
Yes.
Yeah, we haven't gotten that far yet. The first problem we have to solve is building the editor UI so that we can get the tooling and everything in place, and then we can start looking at the runtime UI.
Okay, second question. You mentioned the asset bundle patching. Is that also something about the whole build patching? So something. When I release the build of my game and I have a new version of it, is there something that I can patch it without the asset bundles?
So the patching solution that we've been working with is specifically revolving around asset bundle content. And that's mostly because we want to move basically all game content into asset bundles, because it's a very dynamic way for us to load content and unload content at runtime. So we basically want to get away from the concept of player data as it exists today and only ship asset bundles, but we have a lot of work to do in that part. In terms of patching the DLLs, those we do not have a patching solution in mind just yet for that one, but we'll probably use a similar pretty standard delta patching for that, as it's binary application binary content, so maybe something like a standard X delta or type of solution or something of that nature.
Okay, thanks.
The non-real-time video capture capabilities that you showed in the keynote, any possibility of including that in the runtime so we could expose that to our end users to make videos of the game we're making?
We can pass that on to the team working on it.
Cool.
That information. I'm not sure if we're supporting that yet.
Okay. Cool.
Well, I'm sure we're not supporting it yet.
Yeah.
Like that part is clear. I don't think anyone here would know like how much the current implementation, like how tied it is to the editor. Okay. But like it makes total sense. It makes total sense.
Cool. Thank you.
In the presence of nested prefabs in that vision, do you think the concept of a scene as an asset still makes sense? I mean, these are basically two different things doing the same. A prefab, a nested prefab, and a scene is basically the same thing. And they even have, well, there is a scene editor, and you guys are working on a prefab editor, which is the same. Now, instead of working with two different entities, maybe for a lot of people, it would be just easier to work just with prefabs and scrap the concept of scenes as assets at all, completely.
I mean, they're similar concepts in the way that they contain game objects and stuff, but we see it quite differently in the landscape of, a scene is a massive collection of things, right? Like it represents your world at times, it represents a lot of large things, and prefabs can certainly stack to achieve that, but the prefab editor you saw is more of a local context looking into an object or a smaller portion of it, like almost a slice of the asset.
Well, still, if you have a moderately complex game where you don't actually use one scene, your level is when it's loaded, you load a collection of scenes, like to make a maze. It just blurs the line.
Yeah, it's true. Like the line definitely blurs. It does.
I mean, are there any reasons why the scene has to be kept around? Like I know light maps are tied to the scene, like nav mesh has been separated. As far as I know.
The biggest reason why scenes will probably for a very long time stay separate from scenes and prefabs is that First of all, we have baking data that are associated specifically with scenes, right? When you bake, you can open multiple scenes, and then it outputs baking files, and they are really tied to the scene concept. Secondly, prefabs and prefab merging and nesting is actually something we do in the asset pipeline. So that's not something, you know, like loading and unloading scenes happens at runtime, and we make that really efficient, and everything has already been baked out, right? Like if you have these prefabs that you're using to compose your scenes together and they're nested, when you're loading them at runtime, they're all baked out and flattened out. And for that, it's really useful to have that concept of a scene which can be loaded and unloaded just for performance reasons.
The prototype that you saw, where there was a dedicated window, that's not we're not committed to that as an approach. We are playing with other approaches as well, which includes, for example, just reusing the editor views you already have, and just kind of changing the context and things like that. So like, don't think that we're kind of just like duplicating all the work necessarily. That's one of the ideas we're exploring, but there's other options we're considering as well.
Cool. Yeah, nobody else is up here.
Yeah, we can stand here all day.
Apologies if one of the previous questions touched on this and I missed it. The possibility of including a built-in web player as like, so you could integrate that with the UI. So you could like slide open a panel and then show a web page inside of the game and making that cross-platform.
Can you say that one more time?
Being able to, say, display like a Wikipedia article in, you know, in say a UI panel in your application.
Yeah. So there's asset store solutions for that, packages like coherent UI and so on. I don't think we have anything on the roadmap that we want to build in.
Okay.
So yeah, for now, I guess I'd recommend just go with one of the third-party solutions.
Cool.